Everything will be documented in the test plan, so it can be reviewed by the management team and reused for other project. So these are the main advantages or importance that we can have with the help of this test plan. When we have that summarization related to all the scenarios of testing, then we are calling that kind of document as what? Test case specification document. What is the total time it requires? Then we are calling that as a MTBF. Hello everybody, a warm welcome to one and all. Welcome back to the session 6 of Unit 4, and we are in the BCA's 6th semester subject called Software Engineering. In short, it is SE. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So before getting into our 6th session of Unit 4, that's all regarding this test plan. So before that, we'll just have a quick recap of our previous session. So in the last session of this unit, we had a discussion regarding the structural software testing, and also have discussed regarding what are the types we have under that structural software testing, and also we got to know regarding the advantages as well as disadvantages, and what are the tools we have in order to have that structural testing. These are the concepts that which I have discussed in my last sessions. So in our today's session, we will be learning regarding what do you mean by test plan and what is test case specification. Then we'll also see about some of the testing, that is what reliability testing. At last we'll see what do you mean by the system integration testing. Already you know reliability and integration testing. So in our today's session, we're going to learn about all these types in depth. So now we'll see the first topic, that is test plan. So as we all know that first we have gathered a requirement. Once the requirements are gathered, then it will going to be analyzed. Once the analysis done, then design part has to take place. Once the designing is over, coding will going to take place. All the coded or whatever the coding part or programming part is done, then that needs to be tested whether it is working properly or not, right? So for that we have certain plan. So what do you mean by that? When they are doing a testing, in the testing phase we have this test plan. So then what test plan consists of? We'll see now. It's a detailed document. It will be a document which will going to include, or this will describes the test strategy, that specify the strategy of a test, along with that objective, for what purpose we are having this testing, and schedule, what like how much time it will going to take, or estimation. It is related to estimation of cost as well as time, how much time it will require and what is the cost estimation, and also deliverables, at what time we will be delivering the product or a project or a software, and what are the resources required in order to perform a testing for a software product. So all these detail will going to be summarized together, and that will be storing in a detailed document. Then we will be calling that document as a test plan. And also this mainly will going to help us in order to determine the effort needed to validate the quality of the application under the test. So why we are doing this testing? Mainly to measure the quality of a product in a software, right? So here also we are determining or examining the effort which is required in order to validate the quality of a application that we are building here. And also this will going to serve as a blueprint to in order to conduct a software testing activities. So this will going to act as a blueprint. By looking into this detailed summary of all the objectives, schedule, estimation and all, then it would be easy in order to have a testing. So that it will going to act as a blueprint or a blueprint for the document for the software testing activities, that includes defined process and also which is helpful in order to monitor and control by the test manager. So test manager, that person will be there, he is going to handle this test plan. This will going to act as a blueprint. Just looking into that test plan, it will be easy for us in order to make a testing. And also as per the ISTQB, so based on this standard, we have some definition for the test plan. What do you mean by that? We'll see now. Test plan is a document which describing a scope, approach and resources and schedule of intended test activities. What are all the test activities we have? In order to perform that, it will going to specify or it will describe what is its scope. what is the approach we are using, and what are the resources it require, and related to estimation of a scheduling time as well as money. So all the complete document will be considered as what? Test plan, that too as per the ISTQB. This is what? Test plan. So next, what is the importance of having this test plan? How it will going to be helpful? Mainly this will test plan. So when it comes to the test plan, testing team will be there. Apart from the testing team like designer team, development team, debugging team, how they will get to know what is this software or a product is all about? For that we have one document called test plan. This will going to help the outside people like it can be developers, business manager, customer, mainly to understand the details of testing. We can just go with this test plan. And also test plan guides our thinking. It is like a rule book which needs to be followed. This will going to act as a rule book. With the help of that we can understand or we can guide, that will going to guide our thinking. So if you are going in a correct path of testing, then it is also helpful by making use of this test plan. So at last we have this important aspect like test estimation, test scope, test strategies are documented in the test plan. So we will be able to understand what is its scope, what are the strategies we have, estimation or scheduling regarding that completion or deliverables of a software or application. Everything will be documented in the test plan. So it can be reviewed by the management team and reused for other project. So these are the main advantages or importance that we can have with the help of this test plan. So next we'll see about how we are going to write a test plan. Now I got to know it's a detailed document of all the scope, objectives, scheduling, everything needs to be covered. Then how we are supposed to write? As per the standard of this IEEE 829. So based on the standard of this, we have to follow these 8 stages in order to write a test plan. What is the first stage under that? Here you can see that first we need to analyze the product. First we have to analyze for what purpose we are having this product. After that, design the test strategy. We have to design a test strategy. After that, define the test objective. So we have to mention what are the objectives is there under the testing. In the fourth stage, we have to define the test criteria. Once the criteria of a testing is given, then we have to plan for a resource. That is resource planning. Once the resource got planned, then plan test environment. We have to check the environment. Will it going to be suitable for all the environment or not? And also schedule and estimation. Scheduling in the sense how much time it will going to take, and estimation is regarding how many days it will take in order to deliver the product or a project, and what is estimation related to cost. All those things will be covered here. At last we have to determine the test deliverables. We'll summarize now itself. Analyze the product, design the test strategy, define the test objectives, define the test criteria, resource planning, plan test environment, schedule and estimation. At last we have determined test deliverables. So these are the 8 stages we have. By following these stages, we can write a test plan. I hope you all understood regarding this test plan. Next we'll see about this test case specification. This is also one of the document. Then what it will going to describe? We'll see now. It will describe a detailed summary of what scenarios will be tested, how they will be tested, how often they will be tested. All the things which whenever we are testing and how often we are testing, what is the time interval between the testing of one to another one. So when we have that summarization related to all the scenarios of testing, then we are calling that kind of document as what? Test case specification document. And also mainly this will going to specify the purpose of a specific test. For example, if I am doing a unit testing, what that module is all about. So that will going to specify the individual model testing. So here also in the test case specification, that specifies the purpose of each model or specific test and identifies the required input. What is the required input and how it will going to be processed. At last what we are getting as a resultant. And also this provides a step-by-step procedure for executing the test. What is the input and how it will going to be executed, what are the stages we are following, at last what will be the result. All the detail will going to be stored here and outlines the pass or fail criteria for determining the acceptance. So if I am giving an input, whether I am getting a proper output or not, yes or no, even that criteria, pass or fail criteria, is also there in this test case specification. So when you are writing a report or when you are writing a thesis on your project, then this test case specification will be there. At there we have to mention this pass or fail criteria. So what is the input that you are giving? Once the execution is done, what will be the output or a resultant? All the data will be stored there. Then what do you mean by test plan? So this already you know about test case specification, already you know about the test plan. So if I have a collection of test case specification, together we are calling that as a test plan. So you can see here it is a collection of all the test specification for a given area. So here I am doing it for one module and for another module. So all these are the test case specification. So together I can call that as a test planning, or we can call that as a test plan documentation. This is regarding test case specification. So next, so now we'll see about this reliability testing. As the name indicates, reliable in the sense what? Can we trust? That is what the main question. So what in the calculator if I am pressing 2 plus 3? So like we are just going to get the solution like 5. So we don't bother what is happening inside. So we are just relying on that, right? So when we are doing a complex calculation and all, whatever the resultant that it is giving, we are going to trust. That is what reliability. So if something goes wrong, how much time it will going to take in order to recover from that failure? What is its potentiality to overcome from that particular failure? Then we can say that as a reliable system. That means we can trust. In this reliability testing, it is a technique or testing technique that relates to test the ability of a software to function and give an environmental condition that helps in uncovering issues in the software design and functionality. Whatever could be the situation, whatever could be the environment. So in that environment, what is the ability of a software in order to function its potentiality, with the potentiality, how it will going to function. And also in a particular given environment, whether it can be what comfortable environment for the software or a product to be executed, or it can be some unfavorable conditions. So in all the kinds of environment, in all the kinds of functionality, how potentially it is functioning. So in order to test the ability of a software or a product, we will be having this reliability testing. So it is defined as a type of software testing that determines whether the software can perform the failure-free operation for a specific period of time in a specific environment. So this mainly will going to determines whether the software can perform failure-free operations for a given environment for a given time. Within that given time and environment, will it be able to prove itself? That is what we will be checking in the reliability testing. And also mainly it will going to ensure that the product is fault-free and reliable for its intended purpose. So if the reliability testing is passed by a particular product or a project, then we can say that that will going to improve the performance, and also that is fault-free as well as reliable for the intended purpose for what we had developed that particular project or a product. And what is the main objective of this reliability testing? Why we have to do the checking of potentiality of a particular software or application? So mainly to find the perpetual structure of a repeating failure. So why the failure is occurring more redundantly? Like what is the reason of that? So in order to get to know that, we will be having this reliability testing, and mainly to find the number of failures occurring in the specific period of time. So if I have 5 transactions, and what is the number of failed transactions under that? That is what we will be checking here. So within a given time or within a given specific period of a time, what is the number of errors or a fault or failures that we are facing at that time, and mainly to discover the main cause of failure. So your main concern is all regarding failure. How it will be recovered, how much time it is taking place, like how many times failure is occurring, how much time it will take place in order to recover from that failure, and mainly to conduct the performance testing of various modules of a software product after fixing the defects. So in order to get to know all these things, we have to do this reliability testing. And what are the different types of reliability testing we have? So in that first type we have a feature testing. So feature is what? Some characteristics or quality of a software, right? So this will going to follow 3 steps in order to perform this feature testing. Under that, first, each function in the software should be executed at least once. So if I wanted to get to know the ability of a particular feature that we have incorporated in a product or a software, first we have to execute that particular feature or a software, that each function of a software should be executed at least once. Then we will be able to understand how it will going to be performed. And interaction between the 2 or more functions should be reduced. Like we have to reduce the number of interaction that is taking place between 2 or more function, and each function should be properly executed. So if you are following all these stages, then we can say that this pass the feature testing. What is its feature? How efficiently it is performing its function, that we are checking in the feature testing. What is the second type? We have regression testing. Already you know about the regression testing. So if you are changing a previous content, if you are fixing a existing bug, or if we are adding a new feature, if I am removing a existing content, how the system will going to act, or how system is behaving after the changes has been made. That is what we are testing in the regression testing. So it is basically performed whenever any new functionality is added, old functionalities are removed, or the bugs are fixed in an application. And whenever we does all these things, so we are making sure that with introduction of new functionality or with the fixing of previous bugs, no new bugs are introduced in the application. Whatever the changes that we are making for a existing software or a product, that should not introduce any of a new bugs or errors to the system. That is what we will be checking in the regression testing. So next we have a load testing. So mainly to identify or to find out the capability or a loading capacity of a particular application or a software, we will be having this load testing. So in this, carried out to determine whether the application is supporting the required load without getting breakdown. So what is the minimum load and maximum load? So we have to set a threshold. So even if I am giving beyond the load or beyond the maximum threshold, how it will going to behave? Then we are checking its performance, and we are going to perform this load testing in order to check the performance of a software under the maximum workload. So it's not only related to minimum. So when it is reaches to the maximum load, how efficiently it will going to work. That is what we are checking in the load testing. So after this load testing, this reliability testing can be tested, or we can divide that into 3 categories. It can be based on the modeling, measurement as well as improvement. So all these related to reliability testing. Next we'll see what are the measurements we have in order to measure this reliability testing. First we have a mean time between failures. As I told earlier, this reliability testing is all related to failures. Like when it got failed, how much time it is taking in order to recover from that failure, what is the frequent number of failures that we are facing. So in order to discuss regarding all the failures, we have some of the measurement in order to measure that reliability testing. First is related to mean time between failures. In short, it is MTBF. So measurement of reliability testing is done in terms of mean time between the failures. So in order to find this MTBF, we can have this MTTF. What it mean? Mean time to failure. So for example, if I have 10 transactions, out of that 2 transactions got failed, another 8 are passed. So what is the time interval, or what is the time which is taking in order to have the 2 consecutive failures? Then the time interval is considered as what? Mean time to failure. So here the time between the 2 consecutive failures is considered as mean time to failure. Next, what is that? Second one, we have a mean time to repair. So here we had a failure, right? What is the time it is taking in order to recover from that failure will be considered as MTTR. The time taken to fix the failures is considered as mean time to repair. So what is the total time it require, then we are calling that as a MTBF, mean time between failures. That is what? Addition of a time interval of 2 consecutive failures and what is the time it is taking in order to recover from that failure. So, if we are adding these two, then we can get this complete mean time between failures. This is how this reliability testing will going to takes place. We will see the next topic, that is regarding system integration testing. Already you know about the terminology called integration, right? So, when we are combining more than one module in order to check its efficiency, then we will be calling that kind of testing as integration testing. So, when it comes to the system integration testing, we will be combining all the modules. So, in order to do that, first we have to do the individual module checking. So, once it got done, then we can have this system integration testing. So, it is a testing defined as a type of software testing carried out in an integrated hardware and software environment to verify the behavior of a complete system. So, here we are both combining hardware as well as software in order to verify its behavior when we are having a complete system. That kind of testing is considered as what? System integration testing, SIT, system integration testing. And it is a testing which is conducted on a complete integrated system to evaluate the system compliance with its specified requirement. Whatever the requirement we are giving, based on that we are checking a combined or integrated version of both the capability of hardware as well as software. And also this SIT is performed to verify the interaction between the modules of a software system. This will going to take place between the different modules. So, each module will be tested independently using unit testing. So, when we are combining this, how each modules are interacting with other modules. So, in order to find that one, we have this SIT or system integration testing, and mainly this deals with the verification of high and low level software requirement specified in the software requirement specifications or data and the software design document. So, what we call SRS and document. So, there we have to mention the requirement, functional and non-functional requirement, whether it is satisfying, like whether it is we are verifying all the conditions whatever we had in the SRS as well as in the software design document. So, we are validated in the testing. Verification will going to be done in this integration testing, and also it also verifies the software system coexistence with other. So, when we are combining a different module, how well it is combining with the other modules. Along with that, we will be testing the interface between the modules of a software application. If I have a module 1 and module 2, how the data will going to be exchanged between those two, what is the interface or a medium that it require, everything will going to be verified here. And in this type of testing, modules are first tested individually, then we will be combining that to make a system. By having this, we can perform this system integration testing. So, next, how this will going to take place, how we are going to get to know the what potentiality of combined or integrated hardware or a software. For that, we have a hardware software integration testing. So, whole or a complete system will be tested. So, before that or prior to that, we have to test each modules. So, once that is done, next we have to do this hardware software integration testing. So, in this hardware software integration testing, is a process of testing the computer software components. So, we are checking the computer software components for high level functionality on the target hardware environment. So, we will be checking the functionality of a software when we are incorporating this software to the targeted hardware. We are checking a potentiality of a software by incorporating it to the target hardware. That is what we will be calling that as hardware software integration. So, the goal of hardware software integration testing is to test the behavior of a developed software. So, our main concern is what? Will this software will going to be work well with the designed hardware? That is what we are checking. So, in this, it will check the behavior of developed software integrated on the hardware component. Main focus is related to software. Will it going to work well with this hardware? That we are checking here. Next, we have a requirement-based hardware-software integration testing. So, based on certain requirement, we are checking if software is working fine or will it going to work fine with the targeted hardware. That is what we will be checking in the requirement-based. So, here requirement-based hardware-software integration testing mainly to make sure that software in the target computer will satisfy the high-level requirement. That has to satisfy the high-level requirement of a hardware by incorporating this software. So next we have a software to software integration testing. So when we are combining the modules of software to another software, will it going to work well? That is what we will be checking here. It is the type of testing of computer software component operating within the host or target computer environment. We are checking the what environment? We are checking is new application is working well with the existing application. That is both are software, right? That we are checking the compatibility between the software by having this software to software integration testing. So, simulating the entire system and on the high level functionality, and also mainly it focuses on the behavior of a CSC, that is computer software components in a simulated host or target environment. And why we are going to have this S2S integration testing? Mainly to use for software integration can be incremental approach. That means it can be bottom up approach, top down approach, or a hybrid approach. So in order to see the compatibility between the different software, we will be having this software to software integration testing. I hope you all understood our today's session. In my coming session, we are going to see the important concept, that is software project management. In short, it is SPM, and also we'll see about the cost estimation. If I wanted to deliver any of a project, then what is the cost estimation is required, and what is the time it will be taking, and how many staff or human resource that we require. That is all will be the concepts of our next session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.